Okay, so recording start. Okay, so yesterday where we were was, so we were trying to solve these quadratic inequalities, remember, and there are a bunch of steps, like millions of steps, but they're fairly straightforward. Okay, so first what you do is you solve the quadratic equation. Okay, in like normal sense, like most of the times it will be able to be factored, and then once you get the values, they become the boundary values of the number line. Okay, and then you have to make sure where the number 0 is. It will be either on the left, middle, or right. Okay, and then you plug in 0 to x, and you get whether you have true statement or false statement. If it's a true statement, you keep the entire region, and if it's a false statement, you throw away the entire region. And then, remember, it's OXO or XOX, right? Okay, and then for the survived regions, you represent each region in terms of the interval notations. Now, so let's do this word problem. Okay, so suppose a tiger. Okay, so all of you are supposed to know what the tiger is. Okay, it's not the tiger, remember, it's tiger, right? And for those who have watched like the Pooh, you know what tiger is. Just kind of like poor tiger, right? So this tiger thing is launched from the ground with the initial speed of 64 feet per second. Its height, s, after t seconds is given by negative 16t squared plus 64t. When will the tiger be at least 48 feet? Okay, so now, first of all, there is a keyword, or I guess key phrase, that makes this problem as inequality problem. And what's the key word in this problem?
At least.
At least, yes. And what is the inequality symbol for at least?
Greater.
Okay, now can it be equal to 48? Yes, right? So it's greater than or equal to, okay? Now, as a side note, what would be the word for less than or equal to? So less than or equal to is the opposite of greater than or equal to. So you have to think about what is the opposite of at least. At most. Okay, so at most means the maximum possible value, so it has to be less than or equal to, but at least means minimum possible value, so that's why it's greater than or equal to. Okay, so now 48, there is what? That's not the time, right? That's the height. Okay, so what does that mean? So we have s is equal to 48, and we have greater than or equal to, so that means what? So that means the setup is negative 16t squared plus 64t is greater than or equal to 48, right? Okay, so that's the setup. Okay, so now this inequality looks familiar because that is, again, a quadratic inequality. So now what do? We set it equal sign, right? Okay, and then we have to solve it. Okay, so now the question is, what do we do to solve this?
Set it equal to 0, so subtract 48 from the right side to the left side.
Okay, so first we subtract 48. So now when you subtract 48, we have negative 16t squared plus 64t minus 48 is equal to 0. And then we come across a small issue, which is equal to what?
Negative.
The negative sign, yes, in front, right? So what does that mean? What do we have to do?
Multiply by -1, change all the signs.
Okay, so 16t squared minus 64t. and plus 48 is equal to 0. Okay. Okay. So now, can we factor this? And if so, so we have a bunch of numbers here, all of which are a little bit big. So can we reduce those numbers? And what can we pull out? So what is the greatest common factor here?
$16.
16, right? Yes. Okay. So it's 16 times what? T squared and minus 4t plus 3 is equal to 0. And now, can you factor t squared minus 4t plus 3 further? Yes, right? So what is that? 16 times -1 and -3, right? T minus 1 and t minus 3, right? And is equal to 0. So t is equal to what? So what are the values of t? So I guess 1 is obvious, right? And then 3 is also obvious. And now, is t equal to 16 as well? Because of that? No, right? Yeah, so it's just 1 and 3, right? Okay, and remember these become the boundary values. Okay, so now what do we have to do? Divide the number line is the next step. Okay, so here we have two boundary values, 1 and 3. Okay, so now, which region contains the 0?
To the left.
The left, right? Yeah, so here is the 0. Okay, so now plugging 0 into where? So that was the inequality, right? Okay, so we have to plug in 0 into this. So what do you get? These two are gone, right? Okay, so you just have what? 0 greater than or equal to 48. And this one is obviously false, right? Okay, so that means what? The left region is out. Okay, so what will happen to the other two regions? Which region will survive?
The middle.
This one, right? Yeah, and that region is out, right? Yes, okay. So what is the survived region? Okay, so the survived region is the middle one, And now, what was the label of the middle region? So middle region means what? In between 1 and 3, right? Okay, so it was this one. Okay, so the middle region means this, in between 1 and 3. So now, go back to the problem. What should be the answer? When will the figure be at least 48 feet? So how should we answer this?
Interval notation.
Okay, well here we don't use interval notation because it's just asking you to find the times that the figure will be at least 48. So how should we say the answer?
Between 1 and 3 seconds.
Between 1 and 3 seconds, right? Yes. Okay, so that means between 1 second and 3 seconds after the takeoff, right? Okay, and it could be 1 second and 3 seconds, right? Because what happens after 1 second and 3 seconds? The figure will be at 48 feet, right? Okay, and anything in between will be what? Greater than 48, right? Okay, so altogether it means at least 48. Okay, so that was kind of the simple word problem. And now the last thing in the section is the rational inequality. Okay, so now the rational inequality is again a bit tricky. I guess I have to zoom out a little bit, I guess. So now the rational inequality is also a little bit tricky, but the good thing is lots of the steps are exactly the same as the steps from the previous one, the quadratic inequality. Okay, so now let's compare. So first one, so what was the step number 1 for the quadratic inequality? Put an equal sign, right? Okay, so here we have it. Now we have a little bit of difference here. The first difference, make one side equal to 0. Okay, so that's kind of different, but it's not too much difference. Okay, now step number 2. So now remember the word rational means fractions, right? Where we could see x in the denominator of the fractions. Okay, so what do we do? Once you make one side equal to 0, for the other side, make the other side as a single fraction. Okay, and now here we have to use the LCD. Okay, so now let's look at a simple example for this step number 2. Okay, so now this is the first difference compared to the quadratic inequality. Okay, so now what is a simple example for this? So for example, what is a good problem? So suppose we have something like this. Okay, and of course, like the other side is equal to 0, like for example. Okay, so now when you subtract 1 from 3/4, you use the LCD, right? Okay, so what do? You put 1/1, and then the denominators are 4 and 1, whose LCD is equal to what? Just 4, right? Okay, so what do? Change the second fraction, right? But leave the first one. Okay, so what do? 3/4 minus 4/4, and then you subtract the numerators, right? So you get 3/4 minus, or 3 minus 4, and then all over 4, right? Which is -1/4. Okay, so that's just a simple problem. But of course, we may have to use a little bit of complicated than like what we have done here. Okay, but we use the same scheme, okay, to express the left-hand side as a single fraction. But that is the first real difference compared to the quadratic inequality. And then we set top equal to 0 and bottom equal to 0 and solve. Okay, so we set each top and bottom equal to 0 and then solve. Now, once we do that, we will end up with two numbers. Okay, and I guess you can guess what we should do next. So generate the number line and divide the region, or divide the number line into regions whose boundary values are from the previous step. Okay, so here I said wall values are from step number 1, but it's actually step number 3. Okay, so it's the same thing as before. And now what did we do next? So now from the regions, we pick a value. Okay, so again, it's the same step as before. Okay, so now again, we have to choose 0. Okay, whichever region that contains the 0, we have to pick a 0. Okay, and we plug that into the inequality. Okay, same thing as before. True statement, which means we keep the region. And false statement, we throw the region away. Okay, and another good thing, that OXO and XOX thing, that also holds. Okay, so again, either that or this. Okay, so same thing will hold. So that's another good sign. Okay, so exact same steps 4 and 5. And now, that is another difference, step number 6. Plug in the boundary values to the inequality as well. To the inequality, and repeat step number 5, which is this. Okay, so now what does that mean? So here we are dealing with regions in step number 5, but here we are dealing with the values. But if we get the true statement, we don't keep the region, but we keep the value. Okay, and at the same time, if we get a false statement, we throw away not the region, but the value. Okay, so just replace the region by the value and you'll get the same thing. Okay, and now for each survived regions or wall values, write your answer in the interval notation. Okay, so same thing as before. Okay, so there are a little bit of extra steps here. So the first extra step is express the left-hand side as a single fraction, and then we set top and bottom equal to 0 for that single fraction. And then we also plug in the wall values to check the validity of each wall values. Okay, so as you can see, it's a bit trickier than the quadratic inequality. So if you go to the next page, there are only 2 problems. Okay, so it's the exact same problem as before. So can I go to the next page? Okay, so now 6 over x minus 3 is greater than or equal to 1. Okay, so now here again, what was the first step? Pretend that we had equal sign, and then make one side equal to 0, and then for the other side, make it as a single fraction. Okay, so what does that mean? First, what we do is put equal to 1, and then to make it one side equal to 0, we minus 1. Okay, and now we write the left-hand side as a single fraction. And notice that this expression is quite similar with what I wrote down earlier, right? Which was like 3 over 4 minus 1. It's similar, right? But we are dealing with what? Just weird denominator, right? Okay, so now here, what is the LCD?
X minus 3.
X minus 3, right? Yeah, okay. So here, LCD is x minus 3. Okay, and now what do you do? Put 1 over 1, right? And now from here, what do? We multiplied these two ones by 4, right? Which is the LCD. So do the same thing here. Multiply these two ones by x minus 3. So 6 over x minus 3 minus x minus 3 over x minus 3, right? Is equal to 0, of course, okay? And now we can subtract the tops, right? Okay, so what do you get? 6 minus, and then be a little bit careful. You are subtracting this x minus 3 from 6, right? So what do you have to do? So you are literally doing what? Distribute the negative sign, right? Okay, so you are doing with 6 minus 3 or 6 minus x, and then what? Plus 3, right? Okay, it's not minus 3. Be careful. And then all over x minus 3, right? And so we can just simplify a little bit at the top. 9 minus x over x minus 3 is equal to 0. Okay, and now from here, I think one person from yesterday, when that person turned in the extra credit homework, made this mistake. So now from here, you cannot cancel out the x's, right? Like that, because they're not multiplied. Okay, be careful. And you cannot reduce 9/3 like that, because they're not multiplied either. Okay, so it's just that. Okay, and now, once we have a single fraction at the top, what do we do? Set top equal to 0 and bottom equal to 0 and solve. Okay, and then the usual steps, right? Okay, so what does that mean? 9 minus x equals 0 and x minus 3 equals 0. Okay, so now, from the first equation, so what do? You subtract 9 and change the sign, right? Okay, so what do you get? X is equal to 9. And from the bottom, x is equal to 3, right? Okay, so 9 and 3 are what? Our boundary values, right? Okay, so now, once you get these two values, you know what to do. Okay, so now we divide the number line. Okay, so again, there are two walls, 3 and 9, like that. And now, just to label each region, the left-hand side region means anything less than or equal to 3. The middle one, in between 3 and 9. The right region, greater than or equal to 9. Now, here, why did I put equal to sign underneath the less than or greater than? Because that's what we had at the beginning, right? We had greater than or equal to, okay? And now, which region contains the 0? Where is the 0? Here, right? Okay, so plug in 0 into x. So what do you get? 6 over negative 3 is greater than or equal to 1. And now what is 6 over negative 3? Negative 2, right? Okay, so negative 2 is greater than or equal to 1. And this is what? False, right? Okay, so that's false. So what does that mean? The left region is out. Okay, so what will happen to the other two? That, right? Right? Okay, so now that's not the end, remember. So now what do we have to do? Plug in the boundary values as well to the inequality, okay? And if we get a true statement, we keep the value. If not, we cross it out, okay? So now plug in the boundary values as well. Okay, so first one, 3. So plug in 3 into the original x, so what do you get? 6 over 0 is greater than or equal to 1, right? And now, what is 6 over 0? Zero? Okay, now, does anyone else have any other opinions?
Is it 6?
Okay. Anyone else have any other opinions? Okay, so you have 3 options: 0, 6, and undefined. Which one is it?
It's
Undefined.
tricky.
Undefined, yes. Okay, undefined. Remember, you cannot have 0 at the bottom of the fraction. Okay, so it's undefined. So now, undefined is greater than or equal to 1. Is that true or false? That's very false, right? Yeah, okay, so that's very false. So 3 is out. Now, plug in 9. So what do you get? 6 over 6 is greater than or equal to 1. And now what is 6 over 6? That's 1, right? So now, what is 1 greater than or equal to 1? Is that true? Yeah, right? Because 1 is equal to 1, right? Okay, so what does that mean? You keep the right wall. Okay, so now let's put everything together. Okay, so now put everything together. What are the survived things? So first of all, the middle region has survived, right? From this picture. Now, however, the left wall is out. And on the other hand, the right wall survives, right? Okay, so now what was the label of the middle region? 3 less than or equal to x less than or equal to 9. Okay, now the left wall, which was 3, so 3 has to be out, but the right wall, which is 9, has to be in. Now incorporate all of that into this inequality. What do we have to do? So again, this is the label of the middle region, but somehow incorporate these. Left wall out and right wall in.
Wouldn't it be 3 greater than x greater than or equal to 9?
Right, so from here, we just have to take out that, right? Okay, so in other words, what does that mean? 3 less than x less than or equal to 9. Okay, then we'll have all of that, right? Okay, so now what's the interval notation of this? Parentheses 3 comma 9 bracket, right? Okay, so that is the tricky thing here for this rational inequality, because sometimes you may get a true statement for one of the wall values, and sometimes you may get a false statement. And if you get a false statement, you should never include that boundary value for your answer, okay? So here, it's parentheses 3 comma 9 bracket. So the right wall is in, left wall is out. Okay, so now that's about a tad trickier than the quadratic inequality. Now, part B. So now, if you look at part B, hopefully you notice that you have huge advantage compared to the previous one. Do you notice them? So what is the first advantage that you have? So remember, what you want is 0 on one side. Do you already have it? Yes, you do. And now, what do you want as well? A single fraction on the left-hand side. Do you already have it? Yes, you do. Okay, so what do you have to do, basically?
At the top and bottom equal to 0.
Right, yeah. So once you set equal to 0, you set top and bottom equal to 0, right? Yeah, okay. So from here, top and bottom equal to 0. So what do you get? X is equal to -1 and 4, right? So these are our boundary values. Okay, and now the next steps are what we already know. So divide the number line. So here we have two regions or two walls, -1 and 4. So now this time the left wall is, or the left region is less than -1. Middle one is in between -1 and 4, and the right one is greater than 4, right? And now this time we don't put the equal sign because we didn't have equal to part in the original inequality, okay? And now where is 0? It's right there, right? In the middle, okay? So now plug in 0 to the inequality, so what do you get? 1 over -4, right? Is greater than 0. And this one is what? False, right? Because that's a negative number and it can't be greater than 0. So that's out, right? So what's going to happen for the other two regions? Keep them, right? Okay? And now, check the walls. So first one, -1. So when you plug in -1 to x, what do you get? -1 plus 1, and what's that? 0, right? And -1 minus 4. So that's what? -5, right? So 0 over -5 is greater than 0. And now, what is 0 over -5?
Zero.
0, right? So 0 greater than 0, true or false?
False.
That's false, right? 0 is equal to 0, not greater than itself, right? Yeah, so that's false. So -1 is out. And now 4. So what do you get? 5 over 0 is greater than 0. And what is 5 over 0?
Undefined.
Undefined. So can undefined be greater than 0? So that's again false. So right wall is out. Okay, so what does that mean? The only survived things are pure left and right regions, right? Okay, and there's no boundary values. They're all gone, right? Okay, so what does that mean? The left region means less than -1. The right region means x is greater than 4, right? And now can we write them into the interval notations? Yes, right? So what's the interval notation of the first one? X is less than -1.
Parentheses, -infinity, comma, -1, parentheses.
Okay, and then x is greater than 4.
Parentheses, 4, comma, infinity.
Okay, and now in between these two intervals,
U.
the U, yes, the union, right? Yes. Okay, so that is the answer. Okay, so that is the end of exam 1 materials. Any questions over these rational inequality? Okay, so that's the end of chapter 1 as well. So now we'll go back to chapter 2. Okay, and remember we have already covered 2.1 and 2.2. And remember 2.1 is not part of any exam, right? Even though we have covered that. Okay, so it's just chapter 1 entirely and then 2.2 for exam 1. And now we'll go to section 2.3, which is kind of long, but it's not too terrible. So now 2.3 is about functions, okay? And maybe some of you have heard the word functions before because it's really popular. Now, a function can be represented in 4 ways. The informal method, which is called the romance, and then the relation, graph, and equations, okay? Now, the first one. So now, this romantic relationship may sound weird, but it makes sense, as you will hear. Now, think of the two situations as mentioned on this paper. So, case A. So that is the situation, okay? So now, here we have that. Okay, and now case B is this. So here's me, and here's my friend, okay? And we have a girl like that. And somehow, we kind of like fall in love with each other, like with the same girl, basically. Okay, so now, between these two situations, which one is better? Okay, now better means causes less trouble.
You dating two girls causes less trouble because you can get rid of one.
Oh, so this one causes less trouble? Well, no, like I'm not getting rid of like anyone, okay? So like these two ladies don't know each other. They don't know they are being dated by the same guy, which is me. Okay, so eventually what does that mean? This one will cause some trouble, right? Especially in between these two ladies, right? There will be some like kind of fist fight, right? But like, what about this? This one is slightly better, okay? So this one is a little bit better than this, okay? So now what's the point? What's the point? In a function, what cannot happen is the same x value cannot go to two different y values. That cannot happen in a function. However, what is fine is two different x values can go to the same y value. Okay, so the same x value cannot go to two different y values. That's not okay. But what is fine is two different x values can go to the same y value. Okay, now that's not going to be on any exam, so no worries. Okay, now the relation. Okay, now the relation, this one is more mathematical. This one is more mathematical. Now, has anyone heard the word relation before? Like in math, like not romantic relationship or like human relationship or whatsoever. So the relation, we have to start with from a point, x comma y, okay? So now we say x is an independent variable, which means the input, and y is the dependent variable, which is the output. And what's the reason? Because normally people plug in numbers to x, right? And you can plug in any number. However, y depends on x in the sense that if you change what you plug into x, the y value also changes, right? Okay, so that's why y is called the output, but it depends on x. But x is independent, and normally we plug in numbers to x, so that's why x is called the input. Now, the relation, on the other hand, means the set of ordered pairs. Okay, and maybe you have seen this notation before. In math, we use this curly bracket thing for the set. Have you seen that? Okay, yeah, so basically it's the group or set of points. Okay, that's what the relation means. So now, what is the function then? The function is a relation such that every x coordinate is different. Okay, so basically every x coordinate in a relation, okay, so that's kind of obvious thing, but just to be more precise, I'm adding that extra part here, okay? So what do you notice? A function is a special case of a relation. Okay, so it's more restricted part. So a function is a relation, the set of ordered pairs, such that every x value has to be different. Now, the next two definitions, these two will appear like 1,000 times in the future. The domain and the range. And hopefully these two are familiar to all of you, okay? So I'm sure all of you have heard the word domain and range. Now, the domain has to do with x or y values. No idea? Have you not heard the domain and range before? Okay.
X, isn't it?
Right, yeah, so the domain is x, right? So it's the set of all x coordinates, okay, in a relation. And then the range is the y values. So range is the set of all y coordinates in a relation as well. Okay. Now, these two definitions will be changing a little bit once we get to other forms of functions, but still the main underlying idea is the domain is x and the range is y. That remains the same throughout any forms of functions. Now, let's look at these two problems. Is the following relation a function as well? And here you see this is a relation. Do you see why? Because the relation means what? Set of points, right? Okay. So here you see what? 3 points, right? -4, 0, -3, 1, and 3, 1. Okay. So this is a relation. And they are contained in this curly bracket. So that's why it's the relation. Now, is this a function? And what do we have to check? So function means every x coordinate is different. So is this a function? Yes, right? Okay. Since x coordinate is different. Okay. Now, sometimes people are confused because here we have two the same y coordinates, -3, 1, and 3, 1. Okay. So now, what does these 2 points represent? So these 2 points mean what? This, right? Okay, x and y. And now remember, have we seen the similar picture like this before? And yes, right there. Okay, so remember, this is okay, but this is not, right? Okay, so yes, the same y coordinates, that does not affect the function. The function is whatever, okay? So now, the second relation, is this a function? Okay, which 2 points cause trouble for being a function?
The first set and the last set.
Right, this one and this one, right? So what do they mean? That and this, right? Okay, and that's not okay, right? That's not okay. Okay, so it's no because -4 repeats. Okay, and remember -4 has to be the x coordinate and it indeed repeats. So that's why it's not a function. Okay, so it's fairly simple. And now, the next problem. So can I go to the next page? Okay, so now, number 2. For each relation, find the domain and the range, and also state whether each is a function or not. Okay, so now remember, relation is the set of ordered pairs. But in part A, we have a picture. So did I tell you a lie that relation is the set of ordered pairs? Okay, I hope not, because otherwise I'll be in trouble for like spreading the false news. But so let's look at this picture closely. So there are a bunch of arrows, right? Okay. Now look at the first arrow here. Can you translate this first arrow into some ordered pair notations, like a point? So this is what comma what?
1 comma A.
1 comma A, yes. And do you see why? Because every arrow starts from group A and they all end up in group B. So what does that mean? That is like X and that is like Y, right? Okay. So first, if we translate all of the arrows into ordered pairs, what we get is 1 comma A, okay, and then now we can translate for all the other arrows as well. So what do we have? 1B, okay, and then let's see, 2B, and then 3A, and 3C, right? Did I count all the arrows? 1, 2, no, 1, 2, 3, 4, 5. I guess so. Okay, and just include them into the curly bracket, then it's the relation, right? Okay, so even though we have a picture, we can translate that into a set of ordered pairs. So it's a relation. Now, is this a function? No, and why not?
Because 1 and 3 are both repeated.
Right? So 1 and 3, they go to different y values, right? Okay, and that's not good for a function. Okay, so it's not a function. Okay, since 1 and 3 repeats. Now, even though it's not a function, can we still find the domain and the range? Yeah, because the domain and the range has nothing to do with something is whether something is being a function or not. So now, what is the domain here? So remember, the domain is what? X values, right? So what kind of X values do we have?
1, 2, and 3.
1, 2, 3, right? Yeah, because that's where all the arrows start, right? So the domain is the X values, and it's 1, 2, and 3. And remember, the domain is the set of X coordinates. So what does that mean? Include 1, 2, and 3 inside a curly bracket, right? Okay. And now, what's the range? So remember, the range is what? The Y values, right? So what are the values in the range?
A, B, C.
A, B, C, right? Yes. And again, the range is also the set of the Y coordinates. So include A, B, and C inside a curly bracket. Okay. And now part B. Okay, so now instead of a picture, we have a table of X and Y values. Is that a problem? Not really. Now, can you translate this table into the relation, the ordered pairs? So what do you have to do here in order to translate? You have to look at what? Each row, right? Like that. Okay, so what do you have here? It's -3, 5, and then 0, 5, and then 3, 2, and 5, 5, right? Okay, and so if we include them inside curly brackets, then we have a relation. Okay, now, is this a function? Yes, right? And what's the reason? Every x value is different, right? Okay. So yes, it's a function since every x value is different. Okay, now, what is the domain?
-3, 0, 3, 5.
Right, the domain is the x values, so it's -3, comma 0, and then comma 3, comma 5, okay, and then include them inside a curly bracket. Now, by the way, here, can you write 3, -3, 0, 5, something like that? Yeah, so the order doesn't matter here, right? As long as you contain these four numbers inside the domain, the order doesn't matter, okay? You can have any order. Now, what's the range?
5, 5, 2, 5.
Okay, 5, 5, 2, 5. Now, do we have to cross out some of the fives? Yes or no? So, is this 5 different from that 5? No, right? It's the same, right? So what do you have to do? Cross out the repeaters. Okay, so what's the range? 5 and 2, right? Okay, or 2, 5, either way. Okay, but the point is you don't need to write the 5s like multiple times, right? Okay, so only 5 and 2 are in the range. Okay, so any questions over these relations? Okay, so it's not too bad. And now the method number 3, the graph. Okay, so now graph is also fairly easy. And we will use vertical line test. Has anyone heard about this test before? Vertical line test, does it sound familiar? Okay, so now here is the statement of the vertical line test. So suppose there is a vertical line. Okay, so there are 3 conditions that need to be satisfied. So number 1, vertical line. And this vertical line has to go through the graph. And condition number 3, it meets the graph at more than one point. If that's the case, the graph is not a function. Okay. Now, once we go to section 4.1, which is, I think we can get there sometime this week. There's yet another line test called horizontal line test, and that's for something else. Okay. So for the vertical line test, we use it to tell whether something is a function or not. Okay. Now, on the other hand, if the vertical line meets the graph at exactly one point, what does that mean? So greater than one point, it's not a function. Exactly one point, it will be a function. Okay. So that's the vertical line test. Now, for the relations, we were able to get the domain and the range. And remember the definitions was the set of x and y coordinates in a relation. Now, what's the problem for the graphs? The problem for the graphs is, so for example, for this graph, how many points are on the graph? Can you even see or count all of the points on the graph? No, it's just like too many, right? This is like infinite number of points, right? So how can you get the domain and the range from the graph? You cannot get the x and y coordinates because there are just so many points, okay? So how do you find the domain in particular from the graph? You have to look at where the x values start and stop. Now here I said start and stop, but I actually mean find the minimum x and the maximum x. Okay, and then to find the range, do the same thing, but this time for the y values. Okay, and again, this means find the minimum y and maximum y. And one more. So for the graphs, the way to represent the domain and the range is use the interval notations. Okay, so now for the domain and the range, from the graphs, we will use the interval notations. And we look at the minimum and maximum x and y values. Okay, so now let's look at the following problems. So for each, state whether it's a function or not, and then find the domain and the range. Okay, so let's look at this part A. Okay, so now first of all, is this a function? Yes, right? And what's the reason? Draw this vertical line, and how many points does it pass through the graph? Don't say 2, because like here I drew like 2 vertical lines, but it's just 1, right? So for a single vertical line, at how many points does it cross the graph? Just 1, right? Okay, so it is a function. And now, find the domain. Okay, and remember the domain is the x values. So what do we have to do? We have to get the minimum x and maximum x, and then we have to write them into the order or the interval notations. So here, what is the minimum x on the graph?
Negative infinity?
Negative infinity, yes. Do you see why? Okay. Now, at the bottom of this curve, you see these 2 arrows? What does that mean? The graph will keep going down, right? Like extending like that. Now, the domain is the x values. So look at what is going on in terms of the x values. So for this left tail here, it's slowly approaching to this side, right? It's slowly going toward the left side. Now, what does this direction mean? That is the negative infinity direction, right? For the x values. Okay, so the minimum x is negative infinity. And now, what is the maximum x?
Infinity.
Positive infinity. Do you see why? So now, look at this right tail, okay? It's slowly approaching this direction, right? Now, even though it's very slow, eventually it will cross the y-axis, right? And it will go toward this direction, right? Maybe at the very bottom, okay? And what does this direction mean? Plus infinity direction, right? So the maximum x will be positive infinity. So what is the domain as the interval notation? That, right? And now what are the symbols? Parentheses, right? Yes. Okay, so that is the domain. Okay, and now the range, which is the y value. Okay, so now what is the minimum y for this graph?
Negative infinity.
Negative infinity. Do you see why? So now you look at the y values, okay? And like I said before, these two portions of the graph keeps going down, right? Now going down means what? It will go at the very bottom, okay, of the xy plane, which is what? The negative infinity direction, right? Okay, so the minimum y is negative infinity. Is maximum y positive infinity? No, what's the maximum y?
4.
4, right? Because that's where the graph ends. Okay, so the maximum y is 4. So now, what is the interval notation? I guess this is fairly obvious. Now, what is the symbol?
Parentheses on infinity, or on the negative infinity, and bracket on the 4.
And bracket on the 4. Does everyone see why? It's not a parenthesis around 4, right? Why? What's the reason? That peak or the maximum point is part of the graph, right? Okay, so that's why we have to put a bracket around 4. Okay, so that's the range. Now, part B. Okay, so now the graph changes. Now the graph changes. Now, what is the name of this graph?
Circle.
Be careful, it's not a circle. Do you see why? If it were the circle, what should be the fact? All of these 4 so-called radius, quote unquote radius, have to be the same, right? But they're different, right? So what's the name of this graph?
It's an oval.
Oval or ellipse, right? Okay, yes. Oops, ellipse. Okay, now, is this a function? No. Why? Because if you draw this vertical line, what's the fact? It crosses the graph at 2 points, right? So it's not a function. So what can you say about the circles in particular? That's also not a function, right? Okay. However, we can still talk about the domain and the range. Okay, so now the domain. So now, what is the minimum x? And what is the maximum x? So what are the minimum and maximum x values?
-4 and 4.
-4 and 4, right? Yeah, because those are the smallest and the largest x values on the graph. Okay, so now the interval notation is -4, 4. Now, what's the symbol around these two numbers?
Bracket.
All brackets, right? Yes, because both values are part of the graph. Okay, and now, can you see what the range is for this graph?
3, -3.
Okay, okay. Now 3, -3, but which number has to come first?
I thought you said it didn't matter.
Well, it doesn't matter for the relations, but this time it's the graph, and it matters for the interval notations, because what you have to write is the smaller number first and then the bigger number, right? So it matters.
Okay, so -3, 3, both in
And
brackets.
yeah, right, so the both brackets, yes. Okay. Again, please not say 3, -3 for the interval notation, and same thing for the domain, like it's not 4, -4, because you always put the smaller number first and then the bigger number. Okay? Okay, so any questions over these vertical line tests? Okay, so it's fairly simple. Now, the last one, the equation. Okay, so now this is a little bit tricky. So to tell whether something is a function or not, so that's not too hard. So there are two ways for you to tell whether something is a function or not. Number one, if you have y to the even power, okay, such as y squared, y to the fourth, and so on, then it's not a function. No matter what happens to x, okay, you cannot have y to the even power in a function. Okay? Now, alternately, if you can sketch the graph of the given equation. Okay, so now what does that mean? We have just seen the way to tell whether something is a function or not from the graph. And what does that mean? Use the vertical line test. Okay, so you can use one of these two methods. Now, how do we find the domain and the range? So if we have a graph, we can look at the minimum x and minimum y and maximum x and maximum y. But what about the equation case? So how do we find the domain and the range algebraically? So let's start with the domain, okay, which is the x values once again. So the fact is the domain of most functions is that. And what does that mean? Everything, right? Okay, so the domain of most functions is everything. However, there are two exceptions: square root and the rational function. Okay, and now let's look at these two special cases. So, square root. Remember, why do we have to be careful with this square root function? Because that's not okay, right? In terms of the real number sense, remember, okay, now we know that's an I, but again, we are not dealing with an imaginary number here. That's not a real number, right? So what does that mean? You have the thing under the square root has to be or cannot be negative. Okay, so that's kind of repeated in the next line. So whatever you have under the square root, it cannot be negative, which means what? It must be, so can it be positive? Oh yeah. Can it be 0? Yes, it can, right? Because what is square root of 0? 0, right? Okay, so it must be greater than or equal to 0. So what is the scheme of finding the domain of the square root? Whatever you have under the square root, you have to set greater than or equal to 0. Okay, so it's the inequality. Okay, so many people set it equal to 0, but no, it's greater than or equal to 0. Okay, greater than or equal to 0 for the square root, and then you solve it. Okay, and then you have to write your answer in terms of the interval notation. Now, the rational function case, which means x appears in the denominator. Okay, so now what does that mean? It's a fraction, right? And why do you have to be careful with this? Because we cannot have a 0 denominator. Okay, 0 denominator, that's not possible, right? We saw that in rational equation case. So what if we get a 0 denominator for some x values? It's called the bad values, remember that? The bad values? Okay, so they are the bad values. So how do you find the domain? To find the domain of the rational function case, set bottom equal to 0 and solve. Okay, so this time we have equal to 0 case, and then we have to exclude those from the number line. So what does that mean? Normally people set that. Okay, so the bottom can't be 0, but it could be 0 for some x values, so they're bad values, right? Okay, so that is the setup. Okay, so set bottom equal to 0 for the rational function, and then exclude them from the number line. And then for the square root, we have to set what's inside the square root to be greater than or equal to 0. Okay, so those are the two special cases. And now let's look at the range, okay, briefly. So now the range is, remember, the y values, and it's tough to find the range. So we will be sketching the rough graph and then find the range from there. So here is the first graph. So what does that mean? Y equals x to the even power. Okay, so now in particular, y equals x squared. Have we seen its graph before? Yeah. How does the graph look like? Looks like that. Remember this? The so-called parabola, right? Okay, now from here, what is the range? From the graph, what's the range?
Zero to infinity.
Okay, now what are the symbols?
Bracket on 0, infinity is parentheses.
Does everyone see that? Okay, so now what does that mean? In other words, y is greater than or equal to 0. Okay, and what's the reason? Because on the graph, what kind of y values are on the graph? So all the positive y values are on the graph, right? What about the 0? It's at the origin, right? Okay, but there's no negative y values on the graph, right? Okay, so that's the range. So what's the difference between the graphs of x squared and x to the fourth and x to the higher even powers? The bottom portion here will be a little bit flatter. Like for example, something like this. Like that. That's the main difference. The range doesn't change. Okay? And now, conversely, can I go to the next page? Okay, so now, conversely, we have x equals y to the even power. Has anybody seen the graph of this equation? So hint, it is kind of a parabola, but the position is a little bit different. That is negative x squared, okay? So it was this one for the y equals x squared, but that opened portion is a little bit different. Where is it? It's this one. Yeah, okay. So it's like that. Now, some people say, well, that's not a function. Oh yeah, I know, it's not a function because it fails the vertical line test, but still we can talk about the range. What is the range here?
Negative infinity, comma infinity.
Everything, right? Yes. Okay, because this portion keeps increasing, that portion keeps decreasing slowly. So the range is everything. Yes. Okay. And now go to the odd powers. So y equals x to the odd power. So now this time, how does the graph look like? So in particular, I think we have seen the graph of y equals x cubed. Do you remember its graph? Y equals x cubed. Do you remember its graph? No? Remember this? The snake thing or S-shaped graph? Okay. Now, what is the range for this graph?
The same thing as the one above it.
Right? Same thing, everything. Okay. So again, like as long or when you increase the power, which is the odd number, what happens is this portion becomes a bit flatter, like something like this. Like that's all. Okay, so the range remains the same. Now, conversely, x equals y to the odd power. Okay, so now, has anyone seen the graph of this case? So the hint is it will still maintain the S-shaped graph, but the position is a little bit different. Has anyone seen something like this before? No? Sometimes people say snake for this one, the one before, and then sometimes people say sideways snake for this one. Okay, whatever. Yeah. So sideways snake or regular snake or like, I don't know like why people use snake, but I don't know. You can just use S, like the plain and harmless letter, but snake is sometimes harmful. Anyways, so that's the graph. What is the range in this case?
Same.
Same thing as before, right? Yes. Okay, negative infinity, comma infinity. Okay, so now two more graphs. Y equals square root of x. Okay, now we have seen its graph before for sure. Do you remember how the square root of x graph look like?
Like a hill.
Okay, now, what kind of hill? How does the hill look like?
Start at the X and go.
Right, something like this. Okay, now here, what is the range?
Zero to infinity.
And what are the symbols?
Bracket for 0, parentheses for.
Right, so it's, in other words, y is greater than or equal to 0. Okay, now this is something that we haven't seen before. Y equals 1 over x. Does anyone remember, or has anyone seen its graph? 1 over x. So hint, there are two graphs for this 1 over x. And here is my first hint. Here is the first graph. Where is and how does the other graph look like?
It's in the like opposite quadrant, and it looks the same.
Right, it looks like this. Okay, now here, what seems to be the range?
Negative infinity to infinity.
Everything? Not quite, but close. Everything except one value.
0.
0, yes. Okay, so the range is everything but 0, which means what? Negative infinity, comma 0. And what are the symbols? All parentheses. And then union 0 to infinity, also parentheses. So now, it looks like from the graph that these two portions seem to touch the x-axis, but what's the effect? They do not touch. Okay, so that's why the range is everything but 0, because that's the positive y and that's the negative y, but 0 is not part of the graph. Is there a name for this phenomenon? The graph approaches an x-axis, but it never touches it. And the answer is yes. The name is called asymptote. We will study that in section 3.5. I think that's part of exam 4, I think. So it's coming later. But until then, you don't need to know the asymptote. But remember that 1 over x has the range everything but 0. Okay? So now let's put everything together and let's work on the problems. So for each, the same thing, state whether it's a function or not, find the domain and the range. So part A, y equals x to the power 4. Okay, is this a function? Yes, it is, right? And what's the reason? So here you can use one of these two things. So you can draw the graph and then use the vertical line test, or you can say there's no y to the even power, so it's a function, okay? But I guess the better way is to use the rough graph. So here, how does the rough graph look like? So it's y equals x to the even power, right? So what does that mean? We have this graph, right? Okay, so the graph looks like this. The graph looks like this. So it passes vertical line test. So it is a function. Okay, now, what is the domain of this function?
Negative infinity to infinity.
Everything, yes. Do you see why? So now, go back to this big box here. So now, what did we say earlier? The domain of most functions is what? Everything. But there are two exceptions, the square root and the rational. So are we seeing any square root and the rational here? There's no square root, there's no rational, so the domain has to be everything. Yeah. Okay, again, the reason is no square root or rational. Now, what is the range? Can we see it from the graph? Yeah. So, is it everything? Negative infinity, comma infinity? No. Where does it start?
0.
0, right? And to infinity, right? Do we see bracket around 0? Or is it parentheses? It's bracket, right? Yeah. Okay, so it's bracket 0, comma infinity, right? Okay, you can see it from this graph.
Can I ask a question?
Yeah,
On the previous one,
previous one.
bracket on the 0, on the
Yeah.
y equals 1 over x.
There's no bracket.
Never.
There's no bracket. There's no
I know.
bracket.
I'm asking why.
Why? Because the graphs on this portion and this portion, they do not touch the x-axis. No matter how far you go on this end and that end. It's just a fact. Yeah.
Okay, so on this one, it touches the x, but it doesn't cross it. That's why it's a bracket.
This one?
Yes, sir.
Yeah, so this one, the graph touches the x-axis, but it doesn't go across, yes. So that's why it's the bracket, yes. Okay, so now part B. X squared plus y plus 3 squared is equal to 16. Is this a function? Okay, no, why not? What's the reason?
It has a y to the even power.
Right, so here, at this point, we don't see y to the even power, but once we FOIL it, we will see y to the even power, right? Yes, okay. So, for this, we will see y to the even power, which is 2. Okay. So, it's not a function. Okay. So now, alternately, what you can also say is, can you see the rough graph of this? How does the graph look like? So here's my hint. We can rewrite this as that. Does it look any familiar? How does the graph look like?
Sideways.
Sideways? x minus h squared plus y minus k squared equals r squared. Have we seen that before? A few days ago, I guess.
It's a circle.
Circle, yes. Okay, so the graph is a circle. Now, it's a circle. Where is the center? What's the center of this circle? Zero, -3. Yeah, I know we are covering like lots of things in short period of time, but you have to recognize this form, 0, -3. And what's the radius? 4, right? Yeah, okay. So if we sketch the rough graph, how does the graph look like? So the center is at 0, -3. So 0, -3 is somewhere here. And then it has radius 4, so it looks like this, right? Okay. So now, from this graph, can you see the domain and the range? So here, even though we are not seeing the square root and the rational function, is the domain and range everything? No, right? So what is the domain? So to tell the domain, we have to find the minimum x and the maximum x. So what is the minimum x for this graph?
-4,
And what's the maximum x?
4.
4, yes. Do you see why? Because from 0, -3, you go left 4 and right 4, right? Okay. So the domain is what? Bracket -4, comma 4, right? Okay. And now, what's the range? The range is the y values. So we do the same thing. What are the minimum y and maximum y? So what is the minimum y here?
-7 is the minimum.
And maximum?
+1.
+1, right? Yes. Okay, so -7 and 1. So that means bracket -7, comma 1 is the range. Okay, so even though we don't have the square root and the rational function here, the domain and range are not everything because of the circle. Okay. Now, part C, y equals 3 over x plus 2. Okay, so now first thing first, is this a function? And how do we tell? Can we see the graph, the rough graph of this? How does the rough graph look like? right? So the two curves, this one, right? Okay, now, I know this is not 1 over x, but still it's very similar with 1 over x, so that's why the graph will have two curves which is formed in the same way as 1 over x. So, does it pass vertical line test? Yeah, okay, so it is a function. Okay, vertical line test. So now, the domain. Is the domain everything? No. Okay, so now, do we have the rational function or square root function here? Yes, we have a fraction, right? Okay, so remember, what do we have to do? For the rational case, what do we have to do? Set bottom equal to 0, and that's the bad value, right? And we have to remove that from the number line. Okay, so what do we have to do? So what's the bottom? X plus 2 and equal to 0. So what does that mean? X is equal to negative 2. So in particular, what does that mean? X cannot be equal to negative 2, right? Because that's the bad value. Okay, so what's the domain in words? It's every x but negative 2, right? So how do you put that into the interval notation? So my recommendation is start from negative infinity, and then imagine that you are walking to the positive x direction. Now, at some point you will hit negative 2, right? But now you are what? Removing that negative 2, right? So what's the symbol do we have to put around the negative 2?
Parentheses.
Right? And then you jump over negative 2. So jump over means what? You don't cross, right? So that's again a parenthesis. And then are you good to go to the positive x direction? Yeah. So that's infinity. So it's that. And then in between these two intervals, that. Okay. So that is the interval notation for the domain, everything but negative 2. And now, what is the range?
Everything but 3?
Everything but, not 3.
Negative 3?
Everything but, everything but, everything but
0.
0, yes. Okay, so everything but 0 was the range for 1 over x. So even though we don't have 1 at the top, it will be the same. Now, question, does that mean everything but 0 is the range for any rational function? And the answer is no. Okay, and this 3 here does not even affect the range. However, we maintain the basic thing only in the rational function, so that's why this is the range, but that's not the range for every rational function. Okay, now y equals square root of 4x plus 1. Okay, so now is this a function? Yes, and what's the reason? How does the graph look like? That, right? Okay, so it passes the vertical line test, so it is a function. Okay, and now the domain, which is the x values. Okay, so now the domain. So remember, is the domain everything? No, right? So go back to about 2 pages ago. So for the square root, what do we have to do? So we know that thing under the square root cannot be negative. So what do we do? Whatever you have under the square root, you have to set it what? Greater than or equal to 0, right? Okay, so what do you have under the square root here? 4x plus 1, right? And that entire thing has to be what? Greater than or equal to 0, right? Okay, again, it's not equal to 0, it's greater than or equal to 0, right? Now, how do you solve for x?
Subtract 1.
And divide by 4, right? Now, do we change the signs?
No.
No, right? Okay, so subtracting things does not result in sign change. And now, even though we are dividing everything by 4, it does not result in sign change either. Why? Because that number is positive, right? Okay, so x is greater than or equal to negative 1/4. So what's the domain? Negative 1/4, comma, infinity. And then what are the symbols? Bracket and parentheses, right? Okay, and now what is the range?
Zero, comma, infinity.
And what are the symbols?
Bracket and a parenthesis.
Right, so this one. Okay, and what's the reason? Because if we go back to the previous page, what was the range of the square root? It was bracket 0, comma, infinity, parentheses, right? Now, even though we don't have x underneath the square root, it does not affect the range. And now, just like the previous problem before, does that mean bracket 0, comma, infinity is the range for any square root function? No. Okay, so again, we are trying to keep things fairly basic, so that's why this is the range. Okay? So again, here, what's important in particular is the square root and the rational function case, because they're just weird. Okay? So, any questions over this equation representation of functions? Okay, so now, the next scheme is the popular one, the function notation. Okay, so now, this function notation is really, really important. So, from before, we know that x is the input and y is the output. So, the way to rewrite this is that. Okay, and now, maybe you have seen this representation before, f and then parentheses x. Now, we do not pronounce this as f parentheses x or f times x. The way to pronounce this is what? F of x. Remember that? Maybe you have heard about it before. Okay, so again, here, what am I saying? Y, which is the output, that's the output, right, is the same thing as this entire f of x. Okay, and this x, which is the input, is where? within the parentheses, right? Okay, so stuff inside the parentheses is the input. Okay, so whatever is inside the parentheses, that's the input. Okay, and then this entire thing f of x is the output, which is y. So later we will see some weird inputs. Okay, and you'll see why I called it weird inputs. And f is just a dummy variable. So we may see things like g of x or h of x and things like that, not just f of x, okay? So let's look at this following problem. So they're fairly basic. So f of x is negative x squared minus 6x plus 4, and g of x is 3x plus 1. Find the followings. Part A, f of negative 3. Okay, so now what do we have to do here? Maybe some of you already know how to do this.
Don't you just plug -3 in for x?
Into x, right? Yeah, okay. So remember, whatever you have inside parentheses, that's the input, which is the x value, okay? So that is the x, which is the input, okay? So what we do is plug in x is equal to -3 to where? F of x, right? Not g. Why? Because it says f of -3, not g of -3, so we use that, right? Not this one. Okay? So what do we do? It's negative, and then -3 squared, and then -6, and then -3 and plus 4, right? Okay? So that's fairly simple to see, but here comes the critical part. How do we simplify this? So first of all, what is negative of -3 squared?
-9.
-9, right? It's not +9. Do you see why? Now here, what do we do first? The negative sign outside or the exponent? According to PEMDAS, we take care of that first, right? Which is +9 and then negative, right? So it's -9. And then the next one is +18 and then plus 4, right? So what is this equal to? +9 plus 4, 13, right? Okay, so that is the output. For the input, -3. And now, g of 1/2. Okay, so now here, what do we do?
Plug 1/2 in as x.
In which function? F or g?
In the g of x.
Right? So that is the input this time, 1/2. So we plug in 1/2 into g. Okay? So what we do is 3 stays the same. Okay, right there. And then parentheses 1/2 and plus 1, right? Now, what does 3 parentheses 1/2 mean? That's multiplication, right? So what is 3 times 1/2? Three over 6. Three over what? Two, right? Yeah, 3 over 2, not 6, right? And now, 3 over 2 plus 1, what's that equal to?
2.5.
Okay, now express that in improper fraction, which means the bigger top. So 2.5 is what? What over 2?
5/2.
5 over 2, right? Yeah, so 1 over 1 and then times 2 here. So 3 over 2 plus 2 over 2, 5 over 2, right? So that is the output, okay? Yeah, normally when we deal with fractions, people gradually become silent. Yeah, just sometimes dead silent, but hopefully fractions become your friends. Yeah, maybe your bad friend, not the best friend, but so fractions have to be your friend eventually, okay?
Why did we not simplify that though? Because that's how
Can we simplify
right?
5 over 2? No.
2.5.
Now remember, expressing it in terms of mixed number is not the simplification. Simplifying means reducing, like when you have something like this, which can be simplified into 4/3, but not 1 1/3 like that. That's not a simplification, that's just rewriting, okay? And I recommend you to use improper fraction like this instead of like 2.5, okay? And now, part C, g of negative r. Okay, now what do we do here?
Plug negative r into the second function as x.
Right? So even though the input is weird, that's okay. Whatever is inside the parentheses, that's the input. Okay, so that's the x value. So plug in x equals negative r into g. Okay, so what do we have? 3 stays the same, and then instead of x, we have negative r and then plus 1. And now, what is 3 parentheses negative r? What's that?
Negative 3r.
Right, yeah, multiplication, right? And then plus 1. Okay, now, do we set that equal to 0 and solve? No, okay, please don't. That is very common mistake that people make, which I don't know why, but somehow they want to set this equal to 0 and solve. Okay, but please don't. That's it. That is the output, which looks weird, but that's because our input was weird. Okay, so that's kind of normal. Now, here comes the main thing for this problem, f of x plus h. Now, as a preview, this thing will reappear in section 2.8, which is right next section. Okay, so at that point, hopefully you remember how to evaluate this. What do we do here?
Plug that whole thing in for x into
Right?
the f.
So, yeah. So here, that is the stuff inside parentheses. So that becomes the input, right? Okay. So what do? Replace x in f by x plus h. Okay. So now, remember what was f of x? It was negative x squared minus 6x plus 4. So what does that mean? Negative sign stays the same. And then instead of x, we have x plus h, right? Squared. So we have negative and then x plus h squared, and then minus 6x. So minus 6 stays the same, and then instead of x, we have x plus h. So it's minus 6 and then times x plus h, and then plus 4 in the back. Okay, it's the same thing, but what confuses people is having the two x's, like here and here. Okay, so if you want, you can think of this as something like this. Okay, then I guess you know what to do. Okay, instead of that smiley face, you have to just plug in x plus h, right? Okay, like that. Okay, but back to this. So now, that is what we have. And now, how do we simplify this? What do we do first? So, for example, how do we simplify negative x plus h squared? What do we do first? Negative sign or square?
Square.
The square, right? Yes. So, x plus h squared. What is that equal to? X squared plus h squared? Is this equal to x squared plus h squared? Right? So what do we do? FOIL it, right? Yes. Okay. So what do we get? X squared plus xh plus hx plus h squared, right? Now, do we have any like terms here? What are the like terms?
XH and HX.
Right? They are the same, right? They look different, but they are the same, right? So what do you have? X squared plus 2xh plus h squared, right? You can write 2hx either way. Okay, now, where is this negative sign? In front of what? So this means negative and then x squared plus 2xh plus h squared, right? It's in front of everything, right? Do you see that? Okay, so how do you clear parentheses? Negative x squared minus 2xh minus h squared, right? Okay, so now go back to this expression here. So that is negative x squared minus 2xh minus h squared. And now how do you clear the second parentheses? You have to distribute to negative 6, right? Okay, so what do you have? The first one, negative x squared minus 2xh minus h squared, and then minus 6x minus 6h, and then plus 4, right? And now, at this point, do we have any like terms? No, right? So that whole thing is the output. Okay, why does it look awful? Well, because our input was kind of ugly, right? Okay, but it's normal that the output looks weird, like this. And remember, we will see this thing again in the next section 2.8, so hopefully you remember what to do when we get to the next section. Okay, so any questions on finding these outputs using the function notations? Okay, so now let's do these two problems which don't take a long time at all. So for each function, find f of 3. Okay, so now, usually, or so far, our function had an equation, okay? But here we just don't see any equation at all. Or rather, this is the relation. How can we use that to find f of 3? Can you see what f of 3 is from this relation?
6.
6, yes. And what's the reason? So remember, 3 is the input, right? Which is the x value. Okay, so now, does any point in this relation have 3 as the x value? And the answer is yes. Which point? Right there. Okay, this means when x is equal to 3, y is equal to 6, right? And this f of 3 denotes the y value, so it's equal to 6, yes. Now, what about in this b? What is f of 3?
20.
20, yes. And what's the reason? Based on how the arrows are moving, that is the x group and that is the y group, right? So what does that mean? Find the x value and it ends up at 20, so f of 3 is equal to 20, yes. So what can you say from these two problems? The expression f of a equals b. So again, what does that mean? That is the input, which is the x value, and that is the output, which is the y. So this is same as what? The ordered pair a comma b. Okay, so f of a equals b, which is just an expression, is same thing as this point a comma b. So for example, f of 3 is equal to 6. That's same thing as what? The point 3 comma 6. And then f of 3 equals 20. This is same thing as the point 3 comma 20. Okay. Okay. So now, before I let you go, has anyone tried the exam 1 review problems? Yeah? Has anyone come across any issues or questions? Not only from the review problems, but from any of the materials that we have learned in chapter 1 and 2.2, which is about the circles. Does anyone want to ask any questions? No? No question? Okay. So if you have any questions, I'll be here until like 12:30 or so. So just feel free to ask any questions. Now, remember, tomorrow you will be accessing Zoom from your phone, okay, or tablet maybe, but not from your computer, because through your computer you have to view your exams. Okay, now if you want, you can upload or like put the exams on your on your phone, but that's not the recommended, because I mean, like, you cannot read all the letters and numbers from your tiny screen on your phone. Okay, so you may want to access exam from your computer so that you can be proctored from your phone or tablet maybe. Okay, so tomorrow you'll be running Zoom from your different device other than computer, and when you're done, you will be waiting, I guess, until everyone else is finished it, and then we will be having a lecture for the remainder of the class. Okay, so it's not the exam and then done. You just take the exam and then wait, and then we'll have a lecture for the rest of the class. Okay, so I'll see you tomorrow at 10. So we'll be starting the exam at 10. Maybe I'll answer your questions at the beginning, but we'll be taking the exam first, and then we'll have a lecture. Sounds good? Okay,
Yes, sir. Thank you.
you're welcome. Have a good rest of the day.
Excuse me, sir.
Yes?
What about the exam at 3:30?
Okay, so now, if you are taking the exam at another time, then you have to come to the Zoom at 11:20 or so. That's where we plan to have a lecture, because that is the end of the exam time. Now, of course, some people, like people may finish the exam before 11:20. So maybe you can try to access the Zoom a little bit before 11:20, maybe like 11:15 or so, and see if anyone is still taking the exam. If not, we will be in the middle of the lecture. But I expect people, like some people, take about like full 80 minutes.
Okay. Yeah, I'll get on around 11:15 or so, 11:20, and
Yeah.
I'll stay quiet just in case.
Yeah. And
Yeah.
if people are still taking exams, I'll maybe like send you a message like via this chat, like Zoom chat function, and I'll let you know that there are like 2 people still taking the exam, so just wait for a few more minutes and something like that.
That sounds great.
All right, I'll see you
All right.
tomorrow.
Thank you. Bye-bye.